Hello, and welcome to today's lesson. We're in our second unit of area volume, and we're on our second lesson. By the end of this lesson, we will be able to calculate the surface area of prisms and pyramids. Okay, calculate the surface area of three-dimensional shapes with missing dimensions. So we'll be able to find some missing dimensions as we're working through filling those pieces so we can get the surface area of that shape. So if you think back, in our previous lessons, we've calculated the surface areas of walls and roofs, but understanding that not all surfaces are rectangular. We're going to see some rectangles in today's lesson, but we're also going to work with some other shapes as well. So when we talk about surface area, it's the sum of the areas of all the faces or surfaces that enclose a solid. That includes both bases or the base if it is a pyramid. And if you think back to one of our earlier lessons, we talked about all the lateral faces. So we have the lateral faces, we need to find the areas of those, and the individual base or both bases in that situation. So why do we need to calculate, why do we want to look at surface area? If you think at any packaging is a surface area situation, if you're trying to build a pool in your backyard and you have one of those kits to put a pool together, that is also a surface area situation. So we've talked about some of those real world examples. We're going to dive right into some of our definitions and calculations here. So when we think about surface area, we're looking to find all the areas of every shape that make up that image. So when we talk about the bases of a prism, we have two shapes that are usually congruent and parallel to each other. Once in a while it is just a singular base if we're talking about a pyramid. And the lateral faces, excuse me for the yawn there, the lateral faces of the shape are usually rectangles, and in most of these cases we're going to be talking about right prisms. Okay, so we're not going to worry about the oblique prism. We're going to work with a right prism because then we know that all of our lateral edges, all of our lateral faces are rectangles. And those rectangles are connecting whatever our two base shapes are. So if I wanted to find the surface area of this right prism shown below, what would I need? I would need two areas of the hexagons. And then as we look at the wraparound shape, we would need 6 areas of the rectangles that wrap around the outside. So if we have 2 hexagons, 6 rectangles, we add up all of that measurement and we would get the surface area of this prism. So when we're looking at surface area of any shape, we always want to think about what are our different measurements. And in this case, we've got the top and bottom, which are both rectangles. So the top and bottom area would be a rectangle that is 4 by 4, and we'll have 2 of those. We have the left and the right side of this shape. Once again, 2 rectangles that are 4 by 8. Okay, so we've got 16 for each of those. We have 32 for the left and right sides. And then we have our front and back. Okay, so when we're talking about surface area, it is truly just finding all of the areas of the surfaces that make up the shape. So our front and back are also 4 by 8 rectangles. So we have 32 there as well. And what we have to remember, since it's a top and bottom, it's a times 2. It's a left and right, it's times 2. It's a front and back, it's times 2. So we have 32, 64, and 64, and we just add all of those pieces together. 64 plus 64 plus 32 equals, and we get 160 for our surface area of the shape. Now, notice we have a slightly different designation here when we're talking about surface area. Okay, so the surface area would equal 160. But it is just the sum of all the areas that make up any given shape. So now, we can talk about the real-world examples. The supplier, the Xbox. We're trying to build their box that they need for shipping, and they need to know how much cardboard do we need to order so we can make sure that we have enough cardboard on stock to make all the boxes so we can ship out all of our product. Okay, once again, very similar to the last problem we had. Okay, we've got the front and back of the shape. The front and back are both rectangles that are 14.5 times 13. Okay, we have the left and right side. The left and right side are both 7.5 times 13 measurements. And then we have the top and bottom. The top and bottom of the box are 7.5 times 14.5. Okay, so we have all of these, and if we want to find the surface area, we have to understand front and back, 2, so we're going to multiply by 2. Left and right, multiply by 2. And we're just going to work through to finish up those measurements. Okay, so when we're looking, we've got 14.5 times 13. Okay, we get 188.5. So we need 2 of those. Okay, so we've got 377 for that piece. Okay, then we move on to our next, 7.5 times 13 times 2. Okay, 195. And then finally 7.5 times 14.5 times 2. Okay, 217.5. And in that situation, we now have all of our different surface areas, and we're just going to add those up. Plus 195 plus 377. Okay, and we get our total surface area of 789.5 inches, square inches of cardboard. Okay, next, looking at a tent. How much canvas is needed to make this tent? Okay, when we look at the tent, we have a triangular prism. So we have 2 triangle bases. So we need 2 areas of the triangle. And then we've got our rectangles. Okay, we have 2 rectangles that are similar for the 2 sides. And then we have 1 rectangle for the bottom. Okay, the bottom is 15 by 12. The 2 sides that we have are 15 by 10. And the 2 triangles that we have, 1/2 base of 12 times the height of 8. Okay, so we have 2 of the triangles, so when we find that 1 area of a triangle, we're going to have to double that. We'll double our 2 sides. So we've got our 150 times 2. Got our 1/2 of 12 is 6. 6 times 8 is 48 times 2. And then we have our 15 times 12. Okay, not trusting myself there, so I'm going to go to the calculator to make sure that we're perfect there for 180. Okay, and that is that singular measurement. So we've got 300, we've got 96, and we've got 180, and we add that all together to create our surface area is the sum of all of these pieces. So we have 180 plus 300 plus 96, and we get 576 for our surface area, and that is square feet. Or we could say feet squared, either way. Okay, but remember, when we're talking about surface area, we're talking about a two-dimensional surface, because if you think about canvas, you lay it flat, okay, but we're using that canvas to build this tent, which is a triangular prism. Okay, now, keep moving on. New shape, we'll look at how the formulas work overall. Okay, so what we're trying to find is how much material we need to make the following swimming pool. Okay, we're also making a cover, so we need the top and bottom. The top and bottom are a 10-sided polygon, so we're going to have to find out the area. So it's going to be 2 areas of the 10-sided polygon, and then we're going to have all of the rectangles that go along. Since it's a regular one, we're going to have 10 area of the rectangles around the outside, okay, and that's going to give us the surface area of the shape, and we're just filling in the pieces. So our area formula for this polygon, okay, 1/2 perimeter times apothem. Our area formula for the rectangle is just base times height, and we're filling in the pieces that we know. We've got 1/2 our perimeter, 10 sides times the side length of 6. Okay, we've got the apothem of 9.233. Okay, so we can multiply that out. That is the area of one of the polygons. We need 2 to be able to build this object. And when we look at our rectangles, base of the rectangle is 6 with a height of 4. So we have an area of one triangle of 24 times the 10 triangles gives us 240 for what we call our lateral area, the area that wraps around the outside of this polygon. And then we have our base area where we've got 60 divided by 2, which is 30. Okay, 30 times our apothem, 9.233. So there is the surface area of one of our polygons. We need 2. And then we have to add our lateral area. So we've got plus 240. And we get our surface area of 793.98. Okay, always looking at our measurements, and in this case it is feet squared. Okay, now we can also find the surface area of a pyramid. What we want to understand about the pyramid is, number 1, what's our base shape? So now we have one area of our pentagon, and then for our lateral area of the shape, we've got triangles, and we've got 5 area of a triangle to finish up our surface area for this prism. Once again, we're pulling our area formulas that we have for a polygon, 1/2 perimeter times apothem. For our triangle, 1/2 base times height. And you really have to be careful here. In this case, we have to look at what we call the slant height, because that is the perpendicular distance for this side that is the triangle. We're not looking at the height of the pyramid, which would be from the bottom to the vertex tip. And then we're plugging in our pieces. Okay, 1/2 perimeter, 5 times 5. Our side length is 5. Our apothem here, 1.68. And then when we're looking at our triangles, 1/2 the base of the triangle is the side length of 5, and the height of the triangle is what we call the slant height here of 11. So now we go through to do our multiplication here. So we're going to multiply these pieces out and then put it together to get our surface area. So we have 5.5 times 1.68. Let's try that again. 5 times 5, right? Okay, so we have our wraparound perimeter of 25 times our apothem, 1.68. And we have to multiply that by 0.5, or 1/2. So that is the area of our pentagon, which is 21. Now we need to find the area of our triangles. Okay, so for our triangle, 0.5 times 5 times the height of our triangle of 11. Okay, we get 27.5 for one triangle. We need 5 of those. Okay, so all of our triangles add up to 137.5, and then we need to add on our pentagon to give us our total of 158.5 for our surface area of this shape. Okay, once again, looking at units, we're in centimeters now, so it would be centimeters squared for surface area, because we're looking at a flat 2-dimensional shape. So now, if you think about our goals for today, calculate the surface area of prisms and pyramids. Calculate the surface area of 3D shapes with some missing dimensions. Okay, so we're there. We've got those pieces checked off. And thank you, and have a good day.